single source automation got you stuck between a rock and a giant piece of machinery? Yeah, I get it. Today, industrial automation is more important than ever before, but getting all of your automation solutions from one vendor can be problematic. Sure, it's simple, but it's probably going to cost you a lot more over the long run. You'll have obsolescence, expensive retrofits, and continual license fees to contend with, and a slew of other downsides. The solution? Adopt an open platform that can give you control over your applications and let you customize the architectures of your platform how you see fit. Yeah, let's talk about it. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Ken Crawford from Weidmüller and I investigate the pitfalls of single source automation and why a shift to open platforms can give you the flexibility and connectivity you need for your next IIoT design. We also explore the benefits of Weidmüller's U-Remote I/O systems and how you can utilize the Weidmüller Automation Solutions Network for your next design. And before we get started, don't forget to click that link. There you can find even more information about this topic from Weidmüller. Hi, Ken. Thank you so much for joining me.
Hi there. Glad to be here.
Excellent. Okay, so we're talking about how we can break from our single source automation constraints today. But Ken, before we dig into the solutions in this arena, talk to me about automation.
Well, automation was initially introduced, I guess, in the 18th century in the textile industry with punch card driven looms. Today, automation really refers to automating machines that produce goods in the most effective in cost and time. So from here, you can see there's a machine layer of automation where you have actuators like pumps or motors and sensors that can detect temperature or pressure. And these are read by a computer, some kind of a computer. A PLC is really a computer that's a very robust, purpose-built device. And then for the other pieces of automation, of course, you need to program those devices, or you need to kind of visually inspect and see where you are with those devices. And you have programmers that allow specialists to really define the automation process, and that's all done with a programmer. So you have an operator layer as well. Today's automation is really meant to describe either automation of a particular machine or a skid, or maybe automating a process like filling Coke bottles or making carpet. And those automation machines or the automation parts and pieces, the products that make up that function, it could be PLCs, could be a remote I/O. Certainly robotics plays a part in that. HMIs are the human machine interfaces that give you a status of what the machine is doing in a very visual way. You've got SCADA or supervisory control, which is the programmer and another way to visualize what the machine's doing. Sensors and actuators and industrial networks and protocols tie it all together so that all the different parts and pieces are communicating with one another.
That makes sense. Now, Ken, today's automation has seen a shift toward data-driven analytics, right?
Yes, you hear a lot about data and analytics all the time today, really. 15 years ago, most of the operational data on that machine, it stayed on the plant or on the machine itself. Today, that information is mined and interweaved in all the company's operational software for optimizing and planning. And in order to do that, you have a typical kind of automation outline that I had in the previous slide. But this time, you're going to take that data and you're going to send it either to a remote server location in the building or maybe up into the cloud. And the analytics piece really are going to be applications and device-driven software that reads and quantifies that data to optimize and break down the product or break down the process. We have also anomaly detection and AI for predictive maintenance and other value-added services that you're seeing come online and intertwine itself with automation.
Ken, explain to me what is meant by single source automation.
Sure. Single source automation is when you get all of your automation solution from a single manufacturer. So this means that all or most of your building blocks that make up your automation solution, from the programmer that I spoke about to the controller and more actually come from a single company, a single vendor, or single provider. They're really not compatible. They don't play well, those solutions, with other solutions. So single source parts and pieces you could get so you can buy your PLCs or your distributed control system or your IPCs all from a single vendor. And that's normally a pretty closed or proprietary platform that doesn't really play or interface with a lot of different other platforms that may be compatible or may offer additional functionality.
Ken, what are the downsides to single source automation?
So when you go with a single source, your options are really limited when you're locked into a company that may or may not be keeping up with the fastest pace of technology. So you're locked into legacy. A lot of times you'll have higher term costs. So there's a lot of cost burden to this. Very costly to change your vendor or change your architecture at that point because you've got so much invested in both material and education from your electricians and the engineers that operate the machinery. You have availability risks. So if one product or one of the platforms, the company can't really provide that to you, your entire machine or your entire process may go down. I mean, think about that a lot. Is what happened with COVID. Obsolescence risk when a particular board's no longer available, the software is no longer running on your computer. So there are a lot of downsides to that. Limited innovation, limited options for you to incorporate new technology, the continual cost for licensing fees, and it's pretty extensive and expensive to retrofit a machine. So there are a lot of risks when you put all of your eggs in that single source automation bucket.
Absolutely. Now, what can my audience do to get out of single source automation?
So what you can do is you can choose a partner that offers an open architected solution. For instance, you can choose a partner that has a similar protocol that your single source automation provider has to provide you with IO. So you have IO options. We have IO that talk to 14 or more different protocols. You can choose hardware that's really designed with the reliability and the ruggedness of a PLC, but really open to other alternatives for the programmer, industry standard programmers like IEC 61131 or other options for programming like Node-RED, OpenVPN. You can choose options that really have a wide variety of industry adopted protocols, really tailored and geared towards the types of machines or equipment that you have deployed, like IO-Link, Modbus TCP, EtherCAT, or Modbus RTU.
So, what kind of solutions does Weidmüller offer here?
So at Weidmüller, we pride ourselves on providing a large number of alternate kind of protocol adapters that allow you to talk to many, many different manufacturers, PLCs, and control systems, everything from Siemens, Allen Bradley, ABB, Modicon, Phoenix Contact, Turk. We have all the protocols that talk natively to those PLC platforms with our U-Remote line. And we have different PLCs, as a matter of fact, that are pretty open architected PLCs that allow you to adopt and move over your Codesys programming solutions, for instance, or other C plus or C plus plus derived code platforms that you may be running today can run on our open architected products. So we have a lot of products that allow interfacing to existing legacy systems, expanding into newer products with our U-Remote to give you additional capability, supplement or augment your existing control system today.
Fantastic. Now, Ken, talk to me more about U-Remote.
U-Remote's a fantastic product. So I don't know if we have enough time today to talk about it, but U-Remote has a lot of interesting advantages and differentiators. One, we're the thinnest at 11 millimeters, we're the thinnest slot distributed IO on the market today. We have a very robust hot swapping technique or capability in the device itself. We have over 100 different modules available, 84 plus different IO modules, 14 plus different protocol modules and or field bus couplers. And all of these really are growing. Every quarter, we're releasing either a new module or a new protocol. These are sold in 31 countries. As a matter of fact, we do 240,000 of these produced modules a year. And if you take them for over the last 4 years, we've got over 7,400 miles, if you stack them all up, of U-remote production in the world today. Fantastic product.
That's impressive. So, Ken, what kind of options do I have within this U remote solution family?
So we have a number of network products for U-remote. So each U-remote has a field bus coupler, which is really the head end that connects all of the I/O slices. And then these head end, what you have is you have standard modules where you can talk Ethernet, EtherCAT, Modbus TCP, basically Ethernet connected devices. And we have eco products, which you can connect up. And the eco products are really more tiered towards a lower cost product, but it is configurable for mass production. So if you already have a system, you've locked down your code and you just want to keep that code exactly the same and then roll out the same code on the same module, and the eco module is good for you there. And we have more traditional legacy type modules that are based on serial, like RS-485 and RS-232 modules.
So, Ken, talk to me more about the standard field bus couplers.
Yeah, the standard field bus couplers really show off how U-remote can work with other single source manufacturers, PLCs, and programmers. So with other PLCs and other programmers, you don't really have to change any of the code. You could just map our I/O to it. Our I/O speaks so many different protocol languages: Profibus, Profinet, EtherCAT, Modbus TCP, Ethernet IP, DeviceNet, CANopen, PowerLink, CC-Link. So we have so many varieties of protocols that it allows a customer really to stock one I/O solution, but be able to talk to many other kinds of PLCs. The inventory simplifies the education on a lot of the engineers and users out there. Our eco products really are geared towards both fast Ethernet, Profinet, EtherCAT, Modbus TCP, and Ethernet IP as lower cost, kind of purpose-built, purpose-programmed field bus couplers to help save money on large deployments.
So, Ken, talk to me more about the features within the U remote.
So as I'd mentioned before, U-remote's a beautiful product, but really what makes it very, very differentiated is you can utilize its small size for very high dense I/O applications. It has an internal web server that allows you to configure and actually troubleshoot and monitor the operation of the device remotely or in front of it with your PC. There's 84 different I/O module types. There's 14 plus different head-end types. It's very hot swappable, and the hot swapping is very interesting because you could actually troubleshoot and hot swap out a module in less than 20 seconds without individually pulling any of the terminations, the push-in terminations. So it makes it very easy to diagnose and troubleshoot problems very quickly. And then because your hinged push-in type connections aren't individually disconnected, it makes it very easy for you to disconnect the I/O and then replace the I/O without miswiring anything and to get a determination if that module is good or bad. Also, the fact that you don't have to remove the U-remote device from the DIN rail or separate the slices, because sometimes you'd have components on the left-hand side and components on the right-hand side, which would make it difficult to spread it apart. Everything could be troubleshot in situ with the machine running.
Fantastic. Now, Ken, talk to me a bit about the modules within the U remote.
Yeah, the modules within the U-remote are separate power rails. They're very modular construction. There's three basic pieces to it. It has the core base, which remains connected to the DIN rail, and then it's got the smart card and the swing arm. So with the swing arm, what happens if you wanted to troubleshoot or test out a module, the swing arm actually would pivot down or hinge down with all the connections made. And then the smart card, you take the new smart card out of a box. It comes with a little handle, and you pull out the old smart card while the unit's under power, and then you plug in the new smart card in that little guide rail of the base, and then you swing up the swing arm, latch it into place, and then you'll see that the PLC will then indicate that that particular module is being recognized, and you can determine whether or not that fault is present or not. All of the interconnects on these bases in these modules are gold-plated. So spring-actuated, gold-plated interconnects mean that you're going to have a reliable connection every time, and it's going to be corrosion-free.
So, what about the pack controllers Weidmüller offers? Can you talk to me a bit about that?
Yeah, so the pack controllers or programmable automation controllers really differentiate themselves from a PLC in that the pack controllers can actually run multiple programs, not just the PLC program itself. So in our pack controllers, we have spun our own OS, our own operating system on these devices called UOS. And UOS is a very forward thinking, visionary product that we've incorporated first into our WL2000 series and then into our M3000, 4000 series PLC or controllers, where we're really oriented towards IoT, so MQTT communication, remote communication, as well as multi-core, so the M3000's dual core, the M4000's quad core, and they're really architected to run containerized applications. So one container is a Codesys platform that you can run that IEC programmer on this device. You can come to the table with your own C code, your own proprietary control solution that's written on Linux. We'd be able to containerize that and run that concurrently with Codesys on the side. And then you have all the other applications that you can really load onto this another Docker container and operate next to whatever control solution you have. So it really acts like multiple platforms or multiple products, multiple functions in a single integrated, highly integrated platform for control. So very efficient, very fast, and very cost effective.
So, talk to me about the differences between these different solutions.
So you can look at the diagram as going from a lower end unit up to our flagship unit with the M4000. So the WL2000, we've had that PLC in existence for a number of years now, but not on UOS. So it's been on its own proprietary closed programmer. And so you could program that solution in the legacy way. Today, UOS was released last year. And UOS, with that release comes the capability of Codesys, so you can migrate any existing Codesys platform onto this. This is still a very powerful solution, but it's the lower end of capability, and expansiveness is really not there for the kind of expansion that we built into the M3000 and M4000. If you look at the M3000, 4000, you'll see that there's an expansion slot on the left-hand side. So the left-hand expansion will include things like cellular modems or Wi-Fi cards, integral CAN modems or CAN drivers. On the right-hand side of all of these PLCs will be the same U-remote kind of I/O, that is slot I/O that builds out up to 64 slots total per rack. So the left-hand side shows the lower performance all the way up to a very high performance M4000, which is a quad core based unit. And the expansive memory that the flagship M4000 allows you to have more and more application development, more application room on your device so that you can do more things simultaneously.
Okay, so can we step back a bit and talk about open software versus open source software?
So open source, open software is a conversation that I like to have around an open architected platform. So both open source and open software really allow a customer to take a lot of freely available software and in a very a la carte way, stitch these different software products together in order to achieve a solution, an entire solution. And these open software solutions, there's really two levels. There's open source software, and then there's open software. And open source software, just like the name implies, you have access to the actual source code of that software. So there's normally a very large community that has worked on this program or this project or this software package that has made all of the source code available for you to use freely. So you can take that source code, you can take that software and run it natively. And any additions, any incremental functionality that you add to it, you could do that to the source code. But then that additional capability, that new functionality, it belongs to the source code or the open source community that services that software. So any special sauce that you put into an open source software package is no longer your special sauce. It's open to everyone. And open software you still have that freedom to adopt the software, but you don't have access to the source code. So you'll use that product. That product could be a licensed product, so you may pay a fee for its use, but you don't have to write the code. And normally with open software, what happens is they have standard kind of ways that you interface to the product so that you can get the information into the software package, and then the output of that software package could feed another piece of software. So you can build your own software solution in a very rapid way with very little resources and deploy it on your system. And the kinds of systems that make that possible are the UOS-based platforms that we offer today.
So, Ken, for these kinds of IIoT designs, we're looking at a wide variety of different components, right?
Yes. So every IIoT offering has like functionality and unique functionality. So there's a number of tenets that are pretty common in an IoT solution. There's probably 8 tenets where you have connection to the device, you've got collection of data, you've got to communicate that data, you've got security solutions in a VPN or firewall, you have computation. So all of these tenets, all of these core functions can be found in both the open software and open source software communities to put these together. And then typically there will be some special software that's unique to your customer's requirements or your requirements that really is the IP that makes up your special secret or your secret sauce that defines your product or your process. And you'll focus on that core software, either it's a program or it's a piece of C code, and then you'll be able to utilize these other modules very quickly to round out that IoT solution. So there is a lot of different options, and it's not just IoT. These are basic control functions. These are basic functions for sharing that data up to the network to do OEE calculations or to integrate your production line into your MRP, ERP, SAP system.
Can you also address the UOS open architectures a bit? And how does Data Hub manage these different applications?
So UOS is an operating system. It's a hardened operating system that we rolled out. It's a distribution that we maintain. And that OS really offers the core functionality of the pack controller. And then it enables you to do things like operate in Dockerable containers that run concurrent or side-by-side applications, multi-threaded, simultaneous applications. But sometimes you want to get to the lower parts of the controller. So as any PLC, a PLC has I/O, and you may want to access that I/O. So in order for you to gain access across the backplane to other slots and other I/O pieces of the PLC or the controller, you go through the Data Hub, and the Data Hub will manage those requests. And there's different layers of request capabilities. Some request capabilities like MQTT, pub/sub kind of access aren't really high performance or low determination or lower determinant kind of accesses. They're more on the multiple millisecond kind of accesses, not really repeatable. And some are very, very high speed, very precise, low jitter, highly deterministic accesses that would go through things like an API or an SDK in order to go through the ASIC to the backplane. So the Data Hub's job is really to help manage and match the customer's requirements for access to data. It's not only access to the I/O, but it's also access to the lower level features, maybe the Wi-Fi module or maybe the cellular modem module. The drivers that interface that and control that access would go through the Data Hub as well.
So, talk to me about the UOS ecosystem as a whole.
So the ecosystem as a whole, what we've done is on our website, we've pre-qualified or qualified applications that we see in industry that can be utilized on our products. Codesys is certainly one of the first ones that we've done that really showcase the power of UOS and the power of containerization on UOS by allowing the application of Codesys to run on our system, while at the same time, you could load InfluxDB on there. You could load an Ignition product on there. You could utilize their SCADA product as well as our Procon Web or other kind of applications that have been uploaded to our site, and you can download those with very little configuration and have those running. So that's one of the beauties of UOS. And the goal that we have is to have an online community that would share all these different applications and tie them together, like the Data Hub would be able to tie these applications together through the containerization layer. So 19, dealing with your question of how the UOS ecosystem will work, what you see here is you see that there are a number of other companies that provide open software or open architected products that run on a lot of different platforms, similarly to the way that a PC would run a lot of different Microsoft products. These products are industrial in nature, and they're made available on our website. So Siemens has a platform called Industrial Edge. Ignition has a platform that's a very SCADA-like, or it's a SCADA solution. Codesys has a programming solution. So you see a lot of these cloud-based solutions, a lot of these software solutions that can be downloaded from our store or our portal and then loaded on and combined with other applications that we have that are Weidmüller specific, like the IIoT connector, remote access like Ulink that we have that provides a VPN, a secure VPN. We have a telemetry application that allows the controller to talk multiple protocols, many different protocols. We have, tie-ins to Bluetooth for connections to USENT. So all these different applications, it's very much like an a la carte where I get to define the applications that I need to run on my controller to do the job that will ultimately run my process. They're all handled in our ecosystem and all tied together on our controllers through the Data Hub.
Fantastic. Well, what's all included in your automation solutions network?
So ASN, the Automation Solutions Network, or ASN for short, are basically field deployed control engineers that help customers utilize and validate our platforms and their applications. So they're more than just an application engineers. These guys are a merger between application engineers, controls engineers, and developers. They also assist our salespeople and distributors in identifying opportunities that may benefit from our products. And here you can see we do things like technology migration, where we help customers who have a single source automation solution, and we're able to go in and show them how to bridge the gap between the single source and open architected solutions like us and URemote and our PLCs. We can also do site surveys, so we can go into a customer's machine or a customer's plant and recommend upgrade paths to what they have. We act as consultants. We can do some of the controls programming to help customers get off the ground with Codesys. We also do integration and validation. So when we basically promise that the URemote or the UControl will work on their machine, our ASN guys can sit with your engineers or customers' engineers and actually get that machine up and running using our software and using our products. So that's a way to help validate and really accelerate our product's acceptance into your machine. We also do demonstration and training and a lot of solution selling. So technical discovery is one of the fortes of the ASN network, where we can go in with customers or distributors and actually, much like a site survey, identify options to improve or optimize a customer's platform.
Fantastic. Well, Ken, I think that's all I have time for today. Thank you so much for joining me.
Certainly. Thank you for having me.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Weidmüller. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE